What if a rocket intercepted a messenger from another star? Recently, the internet exploded with claims that a Falcon 9 rocket spotted something moving on the surface of 3I Atlas, an interstellar comet older than our own sun. But what's the real story behind this cosmic visitor and the rumors of its interception? The truth is more fascinating than the fiction, revealing the incredible challenges and profound possibilities of chasing these messengers from distant star systems. Let's explore this together. What makes 3I Atlas special? So what's the big deal with this specific comet? Imagine a visitor from a completely different neighborhood, one that holds clues to how other solar systems are built. 3I Atlas isn't just another space rock. It's a pristine sample of an entirely different stellar environment. It was discovered on July 1, 2025, by the Atlas Survey in Chile, a project co-led by astronomer Larry Deneau. That system is designed to spot near-Earth objects, so finding an interstellar guest is a testament to its incredible reach. Astronomers quickly confirmed its hyperbolic trajectory, the telltale sign of an interstellar origin. This object is racing through our solar system at a staggering 58 to 61 kilometers per second. To put that in perspective, you could travel from the Earth to the Moon in a little over 6 hours at that speed. Scientists estimate it could be up to 7 billion years old, predating our Sun. This means it carries a chemical record from an earlier epoch of the Milky Way galaxy. What truly makes it a scientific treasure is its composition. Observations from the Hubble and James Webb Space Telescopes show it's a true comet, complete with a dusty coma and tail carrying water ice, organic molecules and silicate dust from its home star. The Falcon 9 connection debunked. Here's where the story gets twisted. Did a SpaceX rocket really intercept this interstellar traveler? The claim went viral, fueled by a public fascination with SpaceX's capabilities. But the reality is far more routine. Let's look at the facts. On August 18, 2025, a Falcon 9 rocket did launch from Vandenberg Space Force Base in California. However, its mission, overseen by figures like SpaceX's CEO Elon Musk, was to deploy 24 Starlink satellites into a low-Earth polar orbit. This was a milestone for sure, but entirely unrelated to the comet. There has been no spacecraft from SpaceX or any other agency that has intercepted or interacted with 3I Atlas. These kinds of rumors spread easily because they blend a known, dynamic entity like SpaceX with a mysterious celestial event. It's a compelling narrative, but it's pure fiction. The scale of an Earth orbit satellite deployment versus a deep space, high-speed intercept mission is colossal. Furthermore, space agencies are incredibly public about their scientific missions. An operation of this magnitude would be nearly impossible to hide from the global network of professional and amateur astronomers who constantly monitor the skies. The truth is, all Falcon 9 launches in that period were for planned payloads into Earth's orbit. The physics of interception. So, why couldn't we just send a Falcon 9 to check it out? The math is sobering. As physicist Andreas Hein of the Initiative for Interstellar Studies has detailed in mission concepts like Project Lyra, chasing an object moving at over 200,000 kilometers per hour is a monumental challenge. By the time 3I Atlas was identified, it was already hurtling outwards at immense speed. To even attempt a direct flyby, a spacecraft would need an epic velocity change. A Falcon 9 is a workhorse for lifting heavy loads, but it's not designed for the extreme velocity needed in deep space. You'd need a specialized and powerful kick stage that fires after the main rocket has done its job, pushing a small probe to incredible speeds. Even then, the launch window is punishingly narrow. Miss it by a few weeks, and the target is simply too far away and moving too fast to ever catch. Even our fastest spacecraft only achieve their speeds by falling towards the sun. To catch 3I Atlas, we would need a mission planned years in advance, likely involving a massive rocket and complex gravity assists. A luxury we simply don't have with these surprise visitors. Alien chemistry possibilities. This is where the science gets really exciting. What if this comet is carrying chemicals we've never seen before? Astrobiologists like Sarah Seeger at MIT spend their careers considering such possibilities. At an estimated 7 billion years old, 3I Atlas formed in a stellar environment that was likely very different from our own. The water, ice, and organic molecules detected might have structures fundamentally alien to our solar system's chemistry. This opens the door to a profound question related to panspermia, the idea that the chemical seeds of life are spread throughout space by objects like comets. Even more fascinating is the idea of chirality. On Earth, life uses what we call left-handed amino acids. There's no known chemical reason for this preference. Finding the opposite right-handed amino acids on 3I Atlas would be a monumental discovery. It would be powerful evidence for an independent origin of life's building blocks elsewhere in the galaxy. It would be like finding a recipe card written in a language that doesn't exist on our planet, profoundly impacting our search for life beyond Earth, and hinting that the universe is far more creative with its chemistry than we ever imagined. 3 missed opportunities. We're facing a pattern that is becoming painfully clear. In less than a decade, 3 confirmed interstellar visitors have sailed right past us. First, in 2017, came one Oumuamua. This bizarre object baffled astronomers. It showed no visible coma, yet it was accelerating away from the sun, a mystery that led Harvard astronomer Avi Loeb to famously propose it could be an artifact of extraterrestrial technology. By the time we spotted it, it was already leaving. Then, in 2019, 2I Borisov appeared. This one was clearly a comet, giving us our first real look at the chemistry of another solar system. Studies showed it had an unusually high concentration of carbon monoxide, a tantalizing clue that it formed in a very different, very cold environment, but without a sample, it remains a distant observation. Now we have 3I Atlas in 2025, our third confirmed cosmic messenger. It represents another missed chance for a close-up look. 3 unique opportunities, each with its own fascinating mysteries, and 3 misses. It raises the urgent question of how many more cosmic messengers we will simply let fly by while we remain stuck on the sidelines. Future intercept technology. So, are we doomed to just watch from the sidelines forever? Not necessarily. Imagine a spacecraft parked in space, just waiting. That's the core idea behind the European Space Agency's Comet Interceptor mission. Led by principal investigator Geraint Jones. Planned for launch in 2029, this innovative spacecraft won't have a predetermined target. Instead, it will travel to the Sun-Earth L2 Lagrange point, a gravitationally stable spot about 1.5 million kilometers from Earth, and wait, it will lie dormant until astronomers spot a new interstellar object with enough lead time. Once a target is selected, Comet Interceptor will begin the chase. It's 3 spacecraft in one. It will release 2 smaller probes to fly through the comet's coma from different angles, creating a 3D profile of its nucleus and surrounding environment. This isn't the only idea on the table. Some scientists at NASA have proposed concepts for rapid response missions. The goal is to move from passive observation to active pursuit, finally giving us the ability to reach out and touch one of these cosmic travelers. Scientific implications. What if we did manage to grab a piece of another star system? The implications would be, well, just transformative. As cosmochemist Connell Alexander has shown by studying meteorites, analyzing pristine material can totally revolutionize our understanding of solar system formation. Now just imagine doing that for another star. The primary goal here would be to analyze a pristine sample of matter from beyond our solar system. A key technique would be analyzing its isotopic ratios. Isotopes are variants of elements with different numbers of neutrons, and their ratios act like a fingerprint of the stellar nursery where the object formed. This could tell us if it originated in a region rich with the remnants of supernovas, for example. Furthermore, studying its trajectory with extreme precision could reveal subtle secrets. Tiny, unexplained deviations from its path could hint at unknown gravitational effects. And perhaps most compellingly, if we find complex organic molecules, it would really fuel the panspermia hypothesis, suggesting that the building blocks of life are constantly traveling between star systems. We might be looking right at revolutionary chemistry without even recognizing it. Trajectory analysis and mysteries. Let's dig into the path of this cosmic wanderer. The hyperbolic trajectory of 3I Atlas is the smoking gun that proves it's not from around here. Its path is an open curve, meaning it will swing around the sun once and then exit back into interstellar space, never to return. Its high hyperbolic excess velocity, the speed it retains after escaping the sun's gravity, is a key indicator. For 3I Atlas, this speed is around 58 kilometers per second. The object makes its closest approach to the sun on October 30, 2025, at a distance of about 1.4 astronomical units. One of the biggest mysteries, a puzzle that astronomers like Bill Gray have spent years trying to solve for various objects, is its origin. Astronomers use powerful software to run the comet's trajectory backward in time, checking against star catalogs to see if its path aligns with any known star systems it might have passed millions of years ago. So far, no definitive origin star has been found for any interstellar object. They appear to be true wanderers, ejected from their home systems long ago, and drifting through the void for potentially billions of years. The official facts. So, let's separate fact from fiction and lay out what scientists have officially confirmed. 3I Atlas was first detected on July 1, 2025, by the Atlas survey in Chile. The 3I in its name literally means it's the third confirmed interstellar object. Within a day, its hyperbolic trajectory was confirmed by observatories around the world. As leading interstellar object expert Karen Meach has noted, the global coordination to observe these targets is incredible. It is traveling at a velocity of roughly 58 to 61 kilometers per second relative to the Sun. Hubble Space Telescope images from July 2025 revealed a dusty coma surrounding the nucleus. Spectroscopic analysis by both Hubble and the James Webb Space Telescope confirmed the presence of water ice, organic molecules, carbon dioxide, and silicate dust. NASA has officially stated that the object poses no danger to Earth, always remaining more than 150 million miles away. And to be perfectly clear, despite the viral rumors, no spacecraft, including any Falcon 9, has intercepted or is planned to intercept 3I Atlas. All SpaceX launches around that time were for routine satellite deployments. The bigger picture. In the end, the frenzy over a Falcon 9 intercepting 3I Atlas, while factually wrong, highlights a much deeper truth. Humanity is captivated by the idea of reaching out to these cosmic messengers. We've now seen 3 of these objects in just a few years, suggesting they may be common visitors. With projects like the Vera C. Rubin Observatory coming online, our ability to detect them will only increase. This isn't just a scientific question anymore, it's a strategic one. This connects directly to the Fermi paradox, a question famously championed by SETI astronomer Jill Tarter. If the universe is vast and the building blocks for life are being delivered across the galaxy like cosmic seeds, then where is everybody? Do we invest in developing a permanent, ready-to-launch intercept mission? The technology exists, but it requires political will and financial commitment. The decisions we make now will determine if, next time, we are ready to capture one of these cosmic opportunities, or if we will once again watch it disappear into the void, taking its secrets with it. The universe is constantly sending us messages, written in the language of chemistry and physics, carried on messengers like 3I Atlas. While we weren't ready this time, the future of interstellar interception is closer than you think. What secrets will the next visitor reveal, and will we be there to unlock them? If you want to be here for that next great discovery, make sure you're subscribed to Stellar Tech as we continue to explore the biggest mysteries on the edge of the galaxy. Don't forget to like, subscribe, and hit the bell icon. Thanks for watching. Fresh observations are now shedding new light on 3I Atlas, the massive interstellar visitor that's been puzzling astronomers since its discovery. What started as excitement over finding our third interstellar object has transformed into something far more intriguing and honestly controversial. Recent data analysis reveals patterns that just shouldn't exist in natural objects. Orbital characteristics so precise they seem almost intentional. Professor Avi Loeb and other researchers are asking uncomfortable questions. What if 3I Atlas isn't just a comet? What if it's something designed to study us while appearing completely natural? Fresh observations reveal mysteries. Recent months of intensive observation have transformed 3I Atlas from an exciting discovery into astronomy's most controversial object since Oumuamua. Dr. Robert Warwick from the University of Hawaii, who led the discovery team, admits that new data has revealed characteristics that challenge our understanding of natural interstellar objects. The object's behavior patterns have proven increasingly difficult to explain through conventional comet models. Advanced spectroscopic analysis by the European Southern Observatory shows surface composition anomalies that don't match any known class of solar system bodies. Most puzzling is the object's thermal signature, or rather the lack thereof. Despite approaching within 0.7 AU of the Sun, 3I Atlas shows minimal heat emission and no detectable outgassing. Dr. Michelle Bannister from the University of Canterbury noted that objects this size should be streaming gas and dust as they heat up, but we're seeing virtually nothing. The observations have split the astronomical community between those who believe there must be a natural explanation, and others who are beginning to consider more exotic possibilities. NASA's Deep Space Network continues tracking the object, but each new measurement seems to deepen rather than resolve the mystery. The scientific debate. The astronomical community finds itself divided over 3I/Atlas, with heated debates emerging at conferences and in scientific journals. Dr. Alan Fitzsimmons from Queen's University Belfast leads the conventional camp, arguing that extraordinary claims require extraordinary evidence, and we haven't reached that threshold yet. His team maintains that unusual properties can be explained by exotic but natural compositions, possibly involving nitrogen ice or other materials rare in our solar system. However, a growing faction of researchers questions this dismissive approach. Dr. Daryl Seligman from the University of Chicago, who previously proposed natural explanations for Oumuamua, admits that 3I/Atlas presents characteristics that are harder to reconcile with known natural processes. The debate intensified when thermal modeling by Dr. Marco Michelli from the European Space Agency revealed that the object's temperature distribution doesn't match any known natural body. Spectroscopic measurements show absorption lines that appear artificially narrow, suggesting either unknown physics or manufactured materials. Dr. Sarah Seeger from MIT cautioned against rushing to conclusions, but acknowledged that we may need to expand our definitions of what constitutes natural phenomena in interstellar space. The scientific method demands skepticism, yet the mounting anomalies are forcing astronomers to confront uncomfortable possibilities. The artificial origin hypothesis. Professor Abraham Loeb, former chair of Harvard's astronomy department, has emerged as the most vocal proponent of an artificial origin for 3I/Atlas. Building on his controversial Oumuamua research, Loeb argues that the object displays technological signatures that suggest intelligent design rather than natural formation. His analysis focuses on the object's perfect orbital mechanics, unusual surface properties, and lack of expected comet behavior. Loeb's calculations suggest that 3I/Atlas's trajectory shows statistical precision that would be virtually impossible to achieve naturally. The object's approach vector, timing, and encounters with multiple planets create what he calls a reconnaissance pattern consistent with systematic exploration. In his recent paper submitted to Astrophysical Journal Letters, Loeb proposes that 3I/Atlas could be a probe designed to study our solar system while maintaining the appearance of a natural comet. His hypothesis suggests that advanced civilizations might use such camouflaged objects to observe other star systems without detection. Critics argue that Loeb is making extraordinary leaps from limited data, but his mathematical analysis of the object's properties continues to gain attention from researchers who find conventional explanations increasingly inadequate for the mounting anomalies. Unusual detection pattern. The circumstances surrounding 3I/Atlas's discovery reveal troubling patterns that suggest possible stealth capabilities. Dr. Larry Deneau from the Atlas Asteroid Survey noted that the object should have been detected 18 months earlier based on its size and trajectory, yet it remained invisible to all automated survey systems until July 2025. The delayed detection becomes even more suspicious when considering the object's approach vector from the constellation Lynx, a region of sky that multiple survey telescopes regularly monitor. Orbital reconstruction by Dr. Davide Farnochia at NASA's Jet Propulsion Laboratory reveals that 3I/Atlas entered the outer solar system in January 2024, but somehow avoided detection despite passing through well-monitored space. The object's approach direction created additional observational challenges, as it remained positioned in areas of sky that were difficult to observe from Earth-based telescopes for extended periods. Dr. Catalina Donovan from the Linear program admitted that objects this bright should have triggered multiple detection systems, but somehow it remained hidden until practically on top of us. This pattern of avoiding detection until the last possible moment really raises questions about whether the concealment was accidental or intentional, adding weight to theories about possible artificial intelligence guiding the object's approach. Suspicious orbital characteristics. 3I/Atlas's orbital mechanics present statistical anomalies that challenge natural origin theories through their mathematical precision. Dr. Fathi Namouni from Côte d'Azur Observatory calculated that the object's perfect alignment with the ecliptic plane has only a 0.2% probability of occurring naturally for an interstellar visitor. More striking are the object's sequential close encounters with Venus, Mars, and Jupiter, which orbital dynamicist Dr. Mattia Galeazzo from the University of Vienna determined has only a 0.005% probability of happening by chance. The precision of these encounters suggests either extraordinary coincidence or deliberate trajectory planning. 3. Eye-Atlas will pass within optimal observation range of each planet, maximizing potential data collection opportunities about their atmospheric compositions, magnetic fields, and moons. Dr. Alessandro Morbidelli from the Observatory of the Côte d'Azur noted that the trajectory looks almost designed to provide comprehensive reconnaissance of our solar system's major worlds. The object's velocity profile also shows subtle variations that correlate with planetary encounters, suggesting possible course corrections that natural objects shouldn't exhibit. Statistical analysis by Dr. Renu Malhotra from the University of Arizona concluded that the combined probability of all observed orbital characteristics occurring naturally is less than 0.001%, forcing serious consideration of artificial guidance systems. The hidden approach strategy. 3. Eye-Atlas's approach timing demonstrates what researchers are calling strategic concealment that maximizes the object's ability to study Earth while minimizing detection opportunities. Dr. Paul Wiegert from Western University discovered that the object's perihelion passage in December 2025 coincides with Earth's position in its orbit, creating an observational blind spot that has a 7% probability of occurring randomly. During this critical period, 3 Eye-Atlas will be positioned directly behind the Sun from Earth's perspective, making detailed observation extremely difficult while allowing the object unobstructed views of our planet. Celestial mechanics expert Dr. Kleomenis Tsiganis from Aristotle University noted that this timing allows the object to study Earth's electromagnetic emissions, atmospheric composition, and artificial satellite networks without interference from ground-based observations. The approach strategy becomes more sophisticated when considering that 3Y Atlas will emerge from behind the Sun in January 2026 at optimal angles for both radio telescope detection and deep space communication. Dr. Seth Shostak from the SETI Institute acknowledged that if we were designing a reconnaissance mission to study an inhabited planet, this trajectory would be nearly optimal. The implications are unsettling. 3 Eye-Atlas appears positioned to conduct comprehensive Earth observation while maintaining plausible deniability as a natural comet. Scientific opposition and evidence. Despite mounting anomalies, many astronomers maintain strong skepticism about artificial origin theories for 3 Eye-Atlas. Dr. Alan Harris from the German Aerospace Center argues that size estimates remain uncertain, and unusual properties don't automatically imply artificial construction. His team's thermal modeling suggests the object could be significantly smaller than initial estimates, potentially explaining some observed anomalies through natural processes. Dr. Vishnu Reddy from the University of Arizona emphasizes that interstellar objects should be expected to show unusual properties, since they formed in different stellar environments with unknown conditions. Counter-evidence includes spectroscopic data showing absorption features consistent with water ice and rocky materials, though critics note these signatures could be engineered camouflage. Dr. Julie Castillo-Roges from NASA's Jet Propulsion Laboratory points out that we've only studied 3 interstellar objects, making it premature to define what constitutes normal behavior. The scientific opposition maintains that natural explanations involving exotic ices, unusual mineral compositions, or unknown formation mechanisms remain more plausible than extraterrestrial technology. Dr. Bonnie Barati from JPL advocates for continued observation rather than speculation, arguing that patience and data collection will eventually reveal natural explanations for these apparent anomalies. However, each new observation seems to strengthen rather than weaken the case for artificial origins. Ancient origins and anomalous behavior. Age analysis of 3 Eye-Atlas reveals characteristics that seem to defy the natural aging process expected for interstellar objects. Dr. Grigory Fedorets from Queen's University Belfast estimates the object's age at over 7 billion years based on surface composition analysis, making it older than our solar system yet showing no signs of expected cosmic weathering. Objects drifting through interstellar space for such periods should exhibit significant cosmic ray damage, micrometeorite scarring and surface oxidation, yet 3I/Atlas appears remarkably pristine. Most puzzling is the complete absence of a comet tail despite the object's approach to within 0.7 astronomical units of the Sun. Dr. Matthew Knight from the University of Maryland noted that any object containing even trace amounts of volatiles should be outgassing visibly by now, but we're seeing nothing. Structural analysis by Dr. Jean-Baptiste Vincent from the German Aerospace Center reveals density variations that are inconsistent with typical water ice spectra, suggesting either unknown materials or artificial construction. The object's rotation period of exactly 12 hours also raises suspicions, as natural bodies typically show irregular rotation rates due to impact history and gravitational perturbations. These ancient origins combined with anomalous behavior patterns continue to challenge conventional explanations. The stealth hypothesis. The concept of deliberate concealment has emerged as a serious consideration among researchers studying 3I/Atlas, potentially related to dark forest theory implications for interstellar civilizations. Dr. Liu Cixin's theoretical framework, popularized in science fiction but based on real game theory, suggests that advanced civilizations might prefer stealth over open contact to avoid potential threats. Professor Avi Loeb proposes that 3I/Atlas represents what he calls archaeological reconnaissance, a method for studying planetary systems while maintaining the cover of natural phenomena. This hypothesis explains why the object exhibits just enough anomalous behavior to suggest artificiality to careful observers while maintaining plausible deniability as a natural comet. Dr. Jacob Haq Misra from the Blue Marble Space Institute has studied the implications of such stealth strategies, noting that advanced civilizations might prefer observation over contact to minimize risks while gathering intelligence about other worlds. The stealth hypothesis suggests that 3I/Atlas could be collecting data about Earth's technological level, atmospheric composition, and artificial electromagnetic signatures while appearing to be a routine interstellar visitor. Radio telescope monitoring by Dr. Sophia Sheikh at the SETI Institute has detected no obvious artificial signals, but sophisticated probes might use communication methods undetectable by current technology or transmit data during periods when Earth-based observations are impossible. Lessons from Oumuamua. The scientific community's handling of Oumuamua in 2017 provides crucial context for evaluating 3I/Atlas and the importance of maintaining open-minded investigation. Dr. Robert Warwick, who discovered both objects, admits that we missed significant opportunities with Oumuamua by dismissing anomalies too quickly rather than pursuing thorough investigation. The 2017 visitor exhibited unexplained acceleration, unusual reflectivity, and extreme elongation that were initially attributed to natural causes without adequate investigation. Professor Abraham Loeb's controversial artificial origin hypothesis for Oumuamua was largely dismissed by the astronomical establishment, yet alternative natural explanations have proven increasingly problematic under scrutiny. Dr. Daryl Seligman's hydrogen iceberg theory requires formation conditions so exotic they approach the implausible, highlighting the difficulty of finding natural explanations for truly anomalous objects. 3I/Atlas represents a second chance to properly investigate an interstellar visitor with advanced instruments and sufficient observation time. Dr. Thomas Zurbuchen, former NASA Associate Administrator, emphasized that extraordinary phenomena deserve extraordinary investigation, not extraordinary dismissal. The lesson from Oumuamua is clear. When faced with genuinely anomalous objects, the scientific community must resist the temptation to force natural explanations and instead pursue comprehensive investigation that considers all possibilities, including those that challenge our current understanding of what's possible in the universe. 3I/Atlas continues its journey through our solar system, carrying secrets that may fundamentally challenge our understanding of what travels between the stars. Whether it's an exotic natural phenomenon or something more extraordinary, this mysterious visitor has already forced astronomers to confront uncomfortable questions about the universe around us. The patterns are too precise, the timing too convenient, and the behavior too strange to dismiss easily. Subscribe to Stellar Tech for more investigations into cosmic mysteries that blur the line between natural phenomena and something far more intriguing. Have you ever wondered what secrets lie beyond our solar system? Bill Nye recently revealed something that honestly sent shockwaves through the scientific community. Voyager 1 has detected 300 massive objects floating in the depths of interstellar space. After 45 years of exploration, this aging spacecraft continues to make discoveries that challenge everything we thought we knew about the cosmos. These aren't just random space debris. They're mysterious structures that could hold the key to understanding whether we're truly alone in the universe. Today, we're diving deep into Voyager's most mind-bending revelations. The genesis of Voyager's epic journey. Back in 1977, NASA launched what would become humanity's most ambitious space exploration mission. Voyager 1 and Voyager 2 were originally designed for a simple 5-year mission to study Jupiter and Saturn. But these remarkable spacecraft had other plans. The timing was perfect, a rare planetary alignment that occurs only once every 175 years, allowed the probes to use gravitational slingshots to reach the outer planets faster than ever before. What started as a modest exploration of gas giants evolved into the grand tour of our solar system. Voyager 2 became the first and only spacecraft to visit Uranus and Neptune, capturing images that, well, totally revolutionized our understanding of these distant worlds. The mission's success exceeded all expectations, with both spacecraft continuing to function decades beyond their planned lifespan. The secret to their longevity lies in their nuclear-powered systems and robust 1970s engineering. While their computers have less processing power than a modern calculator, their reliability has proven unmatched. Today, nearly half a century later, these cosmic pioneers continue transmitting data from the edge of known space, redefining what's possible in space exploration. Breaking the ultimate barrier. August 25, 2012 marked a historic moment in human exploration. Voyager 1 became the first human-made object to enter interstellar space. At 11 billion miles from the Sun, it crossed the heliopause, the boundary where our Sun's influence ends and the vast wilderness between stars begins. 6 years later, Voyager 2 joined its twin in this cosmic frontier, making them humanity's only ambassadors to interstellar space. The journey to this milestone wasn't easy. As the spacecraft approached the heliopause, they encountered a turbulent region where the solar wind collides with the interstellar medium. This cosmic battleground creates a protective bubble around our solar system, shielding us from the galaxy's harsh radiation. Voyager's instruments revealed that cosmic rays beyond this shield are 3 times more intense than within our solar system's protective embrace. The transition into interstellar space wasn't gradual, it was like stepping from a bustling city into a silent wilderness. The spacecraft's magnetometers detected the sudden change in magnetic field direction, while particle detectors registered the dramatic shift in cosmic ray intensity. This moment represented humanity's first direct contact with the space between stars, opening an entirely new chapter in our cosmic exploration. The mysterious humming of deep space. One of Voyager 1's most intriguing discoveries came in the form of sound, a low, persistent humming detected in the vast emptiness of interstellar space. This cosmic symphony isn't actually sound as we know it, but rather vibrations in the sparse gas that exists between stars. The discovery challenged our understanding of interstellar space as a perfect vacuum, revealing instead a dynamic environment filled with subtle activity. The humming represents the vibrations of electrons in the interstellar plasma, creating what scientists call plasma waves. These waves provide crucial information about the density and temperature of the interstellar medium, helping us understand the conditions that exist in the 99.9% of space that lies between star systems. The consistency of this humming suggests that interstellar space has a more uniform structure than previously thought. NASA's Nicola Fox emphasized the significance of this discovery, noting that no other spacecraft could have made such observations. The detection required Voyager's unique position beyond the heliopause and its sensitive instruments, which continue to function despite the extreme cold and radiation of deep space. This cosmic humming serves as a constant reminder that even in the apparent emptiness of space, there's always something happening. We just need the right tools to detect it. Defying death in the cosmic deep. Voyager's survival story honestly reads like science fiction. These spacecraft were designed to operate for just 5 years, powered by plutonium-238 that, gradually decays over time. As the radioactive fuel ages, it produces less heat, forcing NASA to make increasingly difficult decisions about which systems to shut down. Heaters that were meant to keep instruments warm in the -270°F environment of space, well, those were turned off years ago. Yet somehow, all 5 scientific instruments on both spacecraft are still functioning perfectly. This really defies all engineering expectations and, frankly, puzzles NASA experts who expected the instruments to freeze and fail long ago. The spacecraft's resilience truly demonstrates the exceptional quality of 1970s engineering and the conservative design philosophy that built redundancy into every system. The power situation gets more critical each year, with both spacecraft losing about 4 watts of power annually. NASA engineers are constantly juggling which systems to keep online, always prioritizing the most scientifically valuable instruments. Despite all these challenges, the spacecraft continued to transmit data across the 15 billion-mile void, with signals taking over 22 hours to reach Earth. This remarkable endurance has extended humanity's reach into the cosmos far beyond anyone's wildest dreams. The shape-shifting boundary of our solar system. The heliopause, which is our solar system's boundary, isn't the static barrier scientists once believed it to be. Instead, it's this dynamic, ever-changing frontier that actually moves and shifts like a living organism. Data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer satellite reveal that this cosmic boundary creates unexpected angles and irregularities, really challenging our understanding of how solar systems interact with interstellar space. This discovery helps explain why Voyager 1 and Voyager 2 entered interstellar space 6 years apart, even though they were launched just weeks apart. The heliopause had shifted significantly between their crossings, demonstrating the dynamic nature of this cosmic frontier. Scientists observed the boundary moving at speeds that just contradicted existing models, suggesting that the interaction between solar wind and the interstellar medium is way more complex than previously thought. The implications are, honestly, pretty profound. If our solar system's boundary is constantly shifting, it affects how cosmic rays penetrate our protective bubble and influences the space environment around all the planets. Recent studies published in Nature Astronomy describe these findings as eye-opening, acknowledging that they challenge some fundamental assumptions about heliospheric physics. Future missions, including NASA's upcoming Interstellar Mapping and Acceleration Probe, will help scientists better understand this mysterious boundary. Electronic aphasia in deep space. In May 2023, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude control system started sending garbled, incoherent data back to Earth. Like a person struggling to speak clearly, Voyager 1 seemed to lose its ability to communicate effectively, sending random patterns instead of meaningful telemetry about its health and status. The mystery only deepened when engineers realized that, despite the communication problems, Voyager 1 was actually functioning perfectly. Its radio signal remained strong and stable, which meant the high-gain antenna was still properly pointed toward Earth. The spacecraft's scientific instruments continued operating normally, completely unaware of the communication anomaly affecting their host vehicle. NASA's investigation revealed that the attitude control system had switched to a backup computer that had been dormant for years. A simple command to switch back to the primary computer resolved the issue, but the root cause still remained puzzling. Engineers suspect that cosmic radiation or maybe an errant command from another onboard system triggered the switch, highlighting the challenges of operating decades-old technology in the harsh environment of interstellar space. This incident demonstrated both Voyager's vulnerability and its remarkable resilience, proving that even after 45 years these spacecraft can overcome unexpected challenges. Cosmic IT support across 15 billion miles. Managing Voyager's computer systems presents some pretty unique challenges, honestly, challenges that make Earthbound IT support look, well, simple by comparison. These spacecraft operate with technology from the 1970s, including computers that have just 70 kilobytes of memory. That's actually less than a single smartphone photo. Yet NASA engineers regularly send software updates across the 15 billion-mile void, and, that process takes over 22 hours each way at the speed of light. The programming challenges here are immense. Engineers have to write code in assembly language, the most basic form of computer programming, because get this, the spacecraft don't have operating systems or any advanced programming tools. Every instruction has to be crafted to work directly with the hardware. which really requires intimate knowledge of systems that were designed nearly half a century ago. And the code, well, it has to be absolutely perfect. There's just no opportunity for quick fixes when the nearest technician is 15 billion miles away. These software updates aren't just, routine maintenance, they're actually lifesavers. Over the years, updates have fixed failing hardware components, optimized power consumption, and even activated backup systems when primary components failed. One critical update actually saved Voyager 1 from potential disaster by activating a fail-safe mechanism when a hardware component stopped working. This kind of cosmic IT support honestly represents one of the most challenging technical achievements in human history. And it's what's kept humanity's most distant explorers operational against all odds, revolutionizing our understanding of planetary worlds. Voyager's planetary discoveries, fundamentally changed our understanding of the solar system. Jupiter revealed itself as a world of extremes, with hundreds of massive storms, glowing auroras at its poles, and a complex ring system that's even more intricate than Saturn's. The Great Red Spot, which is a hurricane larger than Earth, had been raging for centuries, really showing us the incredible power of atmospheric dynamics on gas giant planets. Saturn's rings, once thought to be simple bands of ice and rock, turned out to be incredibly complex structures with thousands of individual ringlets and honestly, these braided patterns that just defied explanation. The discovery of spokes in Saturn's rings, those mysterious dark features that rotate with the planet, revealed that ring systems are way more dynamic than anyone ever imagined. But maybe the most shocking thing was the discovery of active volcanoes beyond Earth. Io, Jupiter's innermost large moon, displayed sulfur volcanoes erupting hundreds of miles into space, while Neptune's moon Triton showed nitrogen geysers erupting at temperatures near absolute zero. These discoveries proved that geological activity wasn't just limited to rocky planets, opening up new possibilities for understanding planetary formation and evolution. And most intriguingly, Voyager revealed that Europa and Enceladus likely harbor vast oceans beneath their icy surfaces, making them prime candidates for harboring extraterrestrial life. The Golden Record and humanity's cosmic message. Each Voyager spacecraft carries humanity's most ambitious message to the cosmos, the Golden Record. This 12-inch gold-plated copper disc contains sounds, images, and music representing Earth's diversity, including greetings in 55 languages and natural sounds from wind, rain, and animal calls. The record serves as a time capsule of human civilization, designed to survive for billions of years in the vacuum of space. Carl Sagan, who really spearheaded the Golden Record project, envisioned it as humanity's introduction to any extraterrestrial intelligence that might encounter the spacecraft. The record includes mathematical and scientific information, human anatomy diagrams, and cultural achievements ranging from Bach to Chuck Berry. It represents our species' optimistic belief that intelligence and curiosity are universal traits that could bridge the gap between civilizations. The Golden Record transforms Voyager from mere scientific instruments into cultural ambassadors. Long after their scientific missions end, these spacecraft will continue carrying humanity's message through the galaxy. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of the star, Gliese 445, potentially becoming the first human artifact to enter another star system. This cosmic message represents humanity's profound desire to connect with something greater than ourselves, embodying our species' eternal quest to understand our place in the universe. Legacy of discovery and future exploration. Voyager's legacy extends far beyond its original mission, inspiring decades of subsequent space exploration. The spacecraft's discoveries at Jupiter led directly to the Galileo and Juno missions, while Saturn observations inspired the Cassini-Huygens mission that spent 13 years studying the ringed planet. Voyager 2's brief encounters with Uranus and Neptune remain our only close-up studies of these ice giants, though, future missions are planned for the 2040s. Today, both Voyagers continue transmitting data from interstellar space, with NASA expecting to maintain contact until the late 2020s. The spacecraft will eventually fall silent as their power sources decay, but their journey will continue for millions of years. In about 300 years they'll enter the Oort cloud, and after 30,000 years, they'll leave our solar system entirely to orbit the galactic center. Current missions like Europa Clipper and the planned Dragonfly mission to Titan build directly on Voyager's discoveries, targeting the most promising locations for finding extraterrestrial life. The spacecraft's detection of subsurface oceans on Europa and Enceladus has absolutely revolutionized astrobiology, making these moons priority targets for future exploration. Voyager's story reminds us that the greatest discoveries often come from pushing beyond our intended limits, proving that human curiosity and engineering excellence can overcome any obstacle the universe presents. From detecting mysterious objects in interstellar space to revealing the hidden oceans of distant moons, Voyager 1 has fundamentally changed our understanding of the cosmos. Bill Nye's revelation about those 300 massive objects reminds us that even after 45 years, these remarkable spacecraft continue making discoveries that challenge our assumptions about the universe. As Voyager drifts ever deeper into the cosmic unknown, it carries with it humanity's greatest hopes and dreams. Thanks for watching Stellar Tech, and don't forget to subscribe for more incredible journeys into the mysteries of space and science.